Hello guys, welcome to this session on categorical data plots. This session is a part of the series data visualization with Python using Seaborn. So we were discussing about Seaborn in our previous lecture. Seaborn is a data visualization library. You can look at the documentation page over here, seaborn.pylata.org. You can see here like all the graphs, all the plots that you can make using Seaborn. And I would like you to like thoroughly go through the especially the galleries page, right? So galleries page will allow you to look at all the different type of plots that you can make. And once you click on any of the plot, you can see one example plot and a very well commented code down below, right? So just in few lines of code you are able to make a data visualization plot like this. Then you can always I would recommend you guys to go through the tutorials page where you can look at different examples and tutorials that are provided by the official developers of the Seaborn library. Right, it will show you an API overview. API is the application programming interface. That means like what is the structure of Seaborn, how it is plotting everything. You can get the overview of Seaborn plotting functions, data structures which are accepted by the Seaborn, and how can you visualize statistical relationships, all that you can look at this particular tutorials page, right? So coming back to our topic of the discussion for today, we will be looking at categorical data plots. So categorical data is a data which is not numeric in nature. So they are not numbers like a weight, like price, like a month or time, right? So it is more about some classes like gender, male or female, like smoker and non-smoker, like some class, okay, cats and dogs, right? Or level 1, level 2, level 3. Okay, so the data which is not numeric in nature but is in the form of some classes, it is called categorical data, right? So now how can we plot categorical data using Seaborn, right? So we'll be looking at factor plots, box plots, Boolean plots, strip plots, swarm plots, bar plot, and count plot. Okay, so we will go through each of these plots one by one, right? So first of all, we start by importing the library, which is Seaborn as SNS. This is a very accepted practice in the Python community. Most of the Python developers use this particular SNS as a representation of Seaborn. Then we do matplotlib inline, which allows us to see our plots in the output cell, right? And just as in the last session, we will be working with a tips dataset which comes within the pre-installed within the Seaborn library, right? So in the tips variable, we are storing this dataset by sns dot data load dataset tips, right? And now let's just look at the dataset tips. This we have seen in the previous session also. So this is a dataset of customers and the bill paid by the customers for a particular restaurant. It contains features like what was the total bill, what is the tip that they gave, what was the gender of the customer, whether they were a smoker or not, what was the day of the week when they came, what time of the meal they took, whether they came for lunch or dinner, or what was the size in which they came, right? So let's start with the bar plot and the count plot. So these are very similar plots, allow you to get aggregate data of a categorical feature in your data, right? So bar plot is a general plot that allows you to aggregate the categorical data based off some function, by default the mean. Okay, so bar plot allows you to aggregate data of a categorical feature. Okay, so like for our example, let's talk about the gender column. So suppose we want, okay, what is the average bill paid by the females in this restaurant? Okay, what is the average bill paid by the male customers in this particular restaurant? What is the count of females that came for dinner on in this restaurant? What is the count of males and females that came on Sunday for on this in this restaurant. Okay, so we are aggregating some data based on a categorical column. So we want some information about like how many females came to the restaurant, what was the average bill, what is the maximum bill paid by the female, like that. Okay, so bar plot and count plot, like it's just, it will give you a count of some feature that you want. Okay, how many meals, how many persons, what how many females came for that particular restaurant for a meal, right? So we will do sns dot bar plot. I want to plot my x should be a categorical column sex, and a y is a total bill, right? It's a numerical column, right? And the data is tips. So I want to plot from this particular data set, tips data set, plot the gender, sex with total bill, right? This is the plot that I get. So male and female, and total bill is this. So we can very easily say that the total bill paid by males is more than females, because it lies on, because the height of the male bar is more than the female bar. Okay, now let's import numpy, because we want to look at something called the estimator. Okay, so in this plot we are just looking at the mean. Okay, what is the mean of total bill paid by males, and mean of total bill paid by females? So the average or the mean bill paid by male is more than a mean or an average bill paid by a female, right? This is a by default estimator. Now we can choose the estimator to be anything like standard deviation, or maybe variance, or the median, or all of these things we'll see in the statistics and probability part of the course, or like you must have already studied in your 11th and 12th class, right? So we can use any estimator that we want. So here we have imported numpy as np, and we are using standard deviation. So basically we are plotting the gender, sex, and the total bill from the tips data set using sns dot bar plot. And on the y-axis I am having the standard deviation. Okay, so what is the standard deviation of the bills paid by male? So it is more, and the standard deviation of the bills paid by female is less. That means there is more variability in the bills paid by males. Okay, standard deviation is like how much the values are varying, are different from the mean. Okay, so for example, let's say if you are talking about the marks of students in a particular subject, so the mean marks are suppose 70, and the standard deviation is more. That means like there are people who have scored marks as low as 30 and 40, and there are people who have scored marks as high as 90, 95, 99. Okay, and if the standard deviation is less, then and the average remains the same 70, then that means like maximum number of students falls between a range of 10 or 10. Okay, so the minimum, most of the when there are people who have scored marks as close to 70 or 55, and as high as 80 or 85. Okay, that means the spread of data around the mean is called standard deviation. Okay, next plot is the count plot. So this is essentially the same as bar plot, except the estimator is explicitly counting the number of occurrences, which is why we only pass the x value. So count plot we just will just give you the what is the count. Okay, what is the number of males that came to the restaurant, restaurant. Okay, and what is the number of how many bills were paid by females, how many bills were paid by males. So the count plot will just give you the count of occurrences or count of observations, right? So sns dot count plot, simple, this structure remains same throughout. You just have to use sns seaborn dot which plot you want, and some arguments that you have to pass, right? Because it's a count plot, it will give you the count of only one variable, so you will just have to pass x, and the data should be tips, because we are using the tips data set, and the tips is the variable which holds the tips data set. Okay, so male and female. So on the x-axis I have these two genders, because we are using the sex as the my categorical variable which I want to plot. So there can be just two genders as per this particular problem. So I will have male and female, and the count will give me, okay, the count of customers, right? So males are around 150 or more than 159, I think, and females are around 90, right? Then box plot and Boolean plot. So box plots and Boolean plots are used to show the distribution of categorical data. A box plot or box and whisker plot shows the distribution of quantitative data in a way that facilitates comparison between variables across levels of a categorical variable. Okay, so basically box plots and Boolean plots give you a distribution, how your data is distributed, how your data is spread around. Okay, so whether your data has a higher number of occurrences for a particular value, then like there are some values which are less observed, or what is the trend. So it will give you a plot like this. So this particular, so box plot will give you the median, the first quartile, the second quartile, and the inner and outer ranges, IQ or quartile ranges, and these are the outliers, which are like way away from the general trend or general pattern of the data. Right. So suppose we are talking about marks of a student in mathematics of a particular class. So, right. So we're talking about a class and the marks that the student scored in mathematics. So like so the general trend is somebody scored 60, 65, 70, 80, 90, like that. But if a student scores marks like 5 or 6 or just 10 out of 100, then he becomes an outlier. So he is like very different from the general trend of the class, right? So if there are like 50 students in the class and like 48 students scored marks between 60 to 80, and one student and two students scored like 5 and 10, so these two students are very much different from the general trend or pattern of the data. So these are called outliers. So box plot shows you this kind of distribution, right? So this is the minimum, maximum, then the first quartile, the median, the second quartile, then we have this outliers, right? So this is also called a whisker. So box and whisker. So because there is a box and this is the whisker. Whiskers are like the mustaches. If you have seen any cat or any animal from the cat family, they have long whiskers or the mustaches from in like face. Just like humans, we have mustaches. These cat family animals have whiskers. So it looks like a whisker, which gives you the range of the data, and also it gives you some outliers, right? The box shows the quartiles of the data set, while the whiskers extend to show the rest of the distribution, except for points that are determined to be outliers using a method that is a function of the inner interquartile range. Okay, so this is how a box plot looks like. So I will do sns dot box plot. So what should be my x variable? It is day, right? So we have Thursday, Friday, Saturday, Sunday, and the y variable has to be the bill. So I want to plot on which day how much like what was the total bill paid by the customers, right? And all of these columns are a part of the data set tips, and the palette is like the color scheme that I want to have is rainbow, right? So like on Thursday, this is like the total bill distribution. So there are like the generally the bill is around somewhere $15. The mean is around $15, but on some days we got bill as high as 40 and 45, right? On Fridays the mean bill is around the same as Thursday, but as we move towards the weekend, Saturday and Sunday, we see that on Sunday the average bill amount or the median bill amount is quite high, because like most of the people like to go out and eat on a Sunday, right? Because on the weekdays maybe they are working, they prepare their own lunch and their own dinner, but on a weekend like it's a holiday and just like Saturday, so people mostly go out and eat. That's why we see this kind of a trend, right? Now these are oriented in this particular vertically they are oriented, but we can also change the orientation into horizontal orientation by just changing this particular variable or the keyword orient. So if we do orient is equal to h, that becomes like we need to orient all of this horizontally, right? So I can do sns dot box plot, data is tips and the palette is rainbow, and the orientation is horizontal. So basically this will make a box plot of all the numerical variables in my data set. Okay, so I'm getting total bill, what is the distribution of total bill, what is the distribution of tips, what is the size distribution of size, and we will get a box plot which is oriented horizontally. By default orientation is vertical, just like the above one. Okay, next we again look at the tips head data set. Suppose now I want to add some information regarding like whether the customers are smokers or not. Then how can I do that in the same box plot? So I want to plot a box plot of day versus the total bill. So I want to see the total bill distribution of total bills across all days, and I also want to see what is how the distribution depends on whether the customer is smoker or not. So I want to see this particular information in my data visualization. So I can add a parameter called hue, whether they were smoker or not, right? This parameter always has to be categorical. Okay, so I want to just see whether they are smoker or not, the customers, right? And the data is tips and the palette is cool warm. So this is how my distribution looks like. So the blue ones are the smokers and the red ones are the non-smokers. So on Thursday, there are like less smokers and there are more non-smokers. On a Friday, there are also like the distribution looks kind of similar, but the total bill paid by smokers is less than the total bill paid by the non-smokers, because this pink box is slightly above than the blue box. But the situation reverses on a Sunday. So on a Sunday we see like there are a lot of smokers, or maybe like people prefer to choose smoking over non-smoking, right? So like a lot of people smoke because the blue box is way bigger than the red or the pink box. So blue box means the smokers, the customers who are smokers, right? So this is so like with this particular visualization we are able to see the distribution of total bill across the week, Thursday, Friday, Saturday and Sunday. And also we get an information about like how what are the bills that are being paid by the smokers, like so on what days we are expected to have more number of smokers and less number of smokers, right? So this also explains like on weekends, like people feel like people are in a party mode, they feel more relaxed. That's why like most of the people smoke on weekends, right? Next comes the violin plot. So a violin plot plays a similar role as a box and a whisker plot. It shows the distribution of quantitative data across several levels of one or more categorical variables, such that those distributions can be compared. Okay. So basically, this violin plot also shows the distribution of any numerical data across several levels of categorical data, right? So I want to see how my bills or how my tips are distributed across gender or across the days of the week. So I can use a violin plot. So if you look at this picture, a violin plot looks like this. So it is kind of a distribution. Like on this particular white dot that you see at center, it is the mean of the total bills paid by customers on a Friday, right? And this is a distribution. So like where there is very less thickness, that means like very less customers paid that amount of bill, that is like almost zero. And as you go ahead, so like we get a peak at around 10 to 30. So between 10 to 30 we are getting all the peaks. So this is the mean amount that is being paid by any customer. Okay, right? Unlike a box plot in which all of the plot components corresponds to actual data points, the Boolean plot features a kernel density estimation of the underlying distribution. So like all of these data points may not belong to the actual distribution, or actually so all of these bills are not actually observed by the restaurant, but it gives you an overall generalization of the trend. Okay, so it is giving you, okay, this is how my bills are distributed, right? So maybe this kind of a representation or this kind of a visualization is more suitable when your client is like all data scientists or statisticians, because they can easily understand this particular graph. Otherwise you can very well stick to the just to the maybe box plot or maybe just a histogram, right? Also, if you want to add one more particular layer of information to it, then you can use this parameter hue is equal to sex or gender, which will give you the same information but gender wise, right? So now I have on Thursday the red ones are the males and the blue ones are the females, right? So this is the distribution of total bill paid by males on Thursday. This is the distribution of total bills paid by females, right? So this way we can see all of this distribution by gender wise, day wise, right? Right, because since you can see like if you don't want to have this particular double violin plots for each day, you can actually add this particular keyword split is equal to true. So the rest of the thing remains same, right? We are doing the SNS violin plot, x is equal to day, y is equal to total bill, data is tips, and the hue is gender, and we are doing split is equal to true, right? So we are getting a graph, a plot like this, like only the half portion we are getting, because anyway it is a symmetrical. So the left side of the this curve is equal to the right hand side of this curve, because it is showing you distribution. So this looks more clear, right? I can easily compare what was the distribution of males and females on a Thursday with respect to the total bill. Right here we see like most of the bills paid by females were belonging to this particular 10 to 30. Here on the other side, for males, the distribution varied along a very broader range. Okay, and we can see that this is there is all for all these 2 days, these 3 days, the distribution is quite uneven. But on a Sunday, the total bill paid by females is almost as equal to the total bill paid by the males, because the distribution looks even or same, similar, right? Next is strip plot and swarm plot. Okay, so the strip plot will draw a scatter plot where one variable is categorical, right? So basically, strip plot is a plot like this, where you plot all the data points in like random, in like dots. Okay, so for all these dots corresponds to the bill paid by a customer on Thursday. All these orange dot belongs to the bills, total bill paid by any customer on Friday, right? So this is a uh, strip plot. And also, if you want to do something like, so like maybe if you want to take jitter is equal to false, if you do jitter is equal to false and you play this, so like most of these values, so if you do a strip plot, sns dot strip plot, plot day versus y should be my total bill, data is tips and jitter is false, then the Seaborn library will plot all of these points on top of each other, so it is very difficult to discriminate, okay, which data point belongs to which particular which particular data point, right? So there is overlapping of data points. But when, if I do jitter is equal to true, then it kind of adds a random noise to the figure, to the plot, and we can see a more dispersed visualization of the data points. Okay, right? Suppose you want to add one more layer of information, because currently in this particular graph we are not able to make out which one of the customers are male and which ones of the customers are female. So I can always add a third parameter called hue is equal to sex. So I can have gender wise distribution of total bill with respect to the day, and get an information, visual information, right? So I'm doing a sns dot strip plot. X should be my day, y should be the total bills, the data set you being used is tips, and I'm keeping jitter is equal to true so that I get a dispersed view. And on the hue parameter is set to sex, and the color scheme or the palette I'm using is set 1, right? So this is what I get to see. So the red ones are the male and the blue ones are the female, right? So I can clearly see that the different distributions, right? So on a Sunday it is more or less the same, right? On a Saturday we see that the females paid the highest amount of bills, right? On even on the Friday the females paid the highest amount of bills, and the males were like lower section of the total bill, right? Now you want to have a strip you want to have a strip plot, and you want to like have so currently see these points are being overlapped, so we are not able to exactly make out which bills were paid by males and which bills were paid by females. So I can also always do like strip plot and plot day versus total bill, data should be tips, data is true, and hue is equal to sex, parent is set 1, and I can just add a third parameter called split is equal to true. So now I can see like for the particular day, okay, this was the distribution of total bills paid by the males, red ones are the males, blue ones are the females, right? So I can see particularly here in the Friday it is very much clear that highest amount of bill is being paid by females, and there are like more females than males. And on like weekend, Saturday and Sunday, it is like almost equal. But we see that on Sunday there are more number of female customers than the male customers, and the females are the ones who are paying the higher bill. Okay, now suppose you want to have the same violin plot as you have seen before. I want to have day versus total bill, then I can have a total violin plot like this. And now if you want to, suppose you want to have a swarm plot, so swarm plot is like you want to have a scatter plot in the shape of a violin plot, so it looks like this. So basically you have a choice of various categories of plots that you can choose from. Okay, so you can choose any of the plots based on your requirement, or like the which one you think is more pleasing than the other plots. So it is like a swarm plot but made of actual data points. Okay, so it is a swarm plot. So sns dot swarm plot, I want x and total bill. So swarm plot will give you a shape like this, a violin plot made of actual data points, right? Looks in this structure. And the same, if I add a particular uh, parameter called dodge is equal to true, so it has the same effect as split is equal to true. So now I am able to see, I added a parameter called hue, gender, so I can see the information about gender, and I have mentioned dodge is equal to true. That means I get separate. So the red ones are the male and the blue ones are the female, right? So this is what we are getting. Now suppose you want to combine both the plots, then you can, on the first line you can draw a violin plot, and the next line you can do a song plot. So you can combine both the plots together, right? And there is something called factor plot, which allows you to plot different kinds of plot using the same name. So if previously we were doing, like, if I want to plot, I will do sns dot violin plot, sns dot swarm plot, sns dot some other plot if we are working on strip plot, right? So we are calling the name directly from the SNS library or the Seaborn library. But factor plot allows me to have like a generic representation. SNS dot factor plot, I define x column, y column, my data, and the kind of graph that I want. So I can, in the kind, I can define whether I want a scatter plot or a swarm plot or a violin plot, right? So here I want a bar plot, so I will get a bar plot like this, right? If I want in the same vector factor plot, just gender and total bill, I want kind box plot, so I will get a box plot, right? So this is how we can use different categorical plots using the Seaborn library. This is what I had to discuss with all of you. Thanks a lot for your time. I'll see you in the next lecture. Bye bye.